Hello everyone and welcome back to our channel A to Z Automation in Java. Today we are going to discuss about types of memory allocation in Java. So today's topic is types of memory allocation in Java. And in the previous video we have discussed about different types of variables in Java. If you didn't watch it yet, please go back and watch that video. So today we are going to discuss about different types of memory allocation in Java. What is the memory allocation and why we need this one? Basically, to run an application in an optimal way, JVM, Java Virtual Machine, divides the memory into two parts. What are those two parts? The first one is the stack and another one is the heap. So JVM divides the memory into two parts, stack and heap. Whenever we declare any variable, any new variable or an object, or even when we call a method or declare a string or perform similar operations, so JVM designates a memory to these operations from either stack memory or in heap memory. So we can say that whenever we are performing any of the operation like declaring a variable, declaring a new variable or object, second thing is calling a method, calling a new method, declaring a string, or perform similar operations. So these are the major operations which we perform. So on the basis of this, JVM designates the memory to all of these. Either it can be a stack memory or it can be a heap memory. So okay, today we will discuss about and examine these memory models. First of all, we will explore their key features. What are the key features of stack memory and heap memory? Then we will learn how they are stored in the RAM. Basically, these memories are stored in the RAM, random access memory, and where to use these. So after that, we will study about these things. Finally, then we will discuss about the differences between stack and heap memory. Okay, so the first topic here is stack memory. Okay, so if we talk about stack memory, then we can say that stack memory in Java is used to store the static values. Static values means the static memory allocation and the execution of a thread. So stack memory in Java is used for static memory allocation and execution of a thread. What is a thread? These can be there can be a multiple threads which can be executed at the same time in the Java. So the execution of the thread is also handled in the stack memory. Okay, so if we talk about the basic definition, then we can say that stack memory in Java is used for static memory allocation and execution of threads. Okay, it contains primitive values that are specific to a method or reference to the objects. Specific to the method means the values which are defined inside the method. These are stored inside the stack memory. And even the reference variables which we declare for the object. When we are declaring any object, in the previous class we have discussed about how to create the object and declare those. So when we are declaring any object, the reference name which we give is also stored there. Okay, so in order to access the stack memory, the access to this memory is in last in first out order. Means the last variable or method which we are going to store in the stack memory will be out first. It is something like that in the form of a bucket. Suppose if you are entering anything inside the bucket, then everything is getting added on. The first thing which you entered will go at the bottom section, then another thing come up on that one, then another one. So in this way you can say that the last thing which is coming inside will go first out. Last in will be the first out. This will be the order for that one. Okay, so when the method execution finishes, then the stack memory which was declared to that particular method, because we can say that declaring a method, the methods are stored inside the, we can say that the methods are stored inside the stack memory. Okay, the memory which is allocated to the method is stored in the stack. When the method execution started, then the stack memory is allocated to that particular method, and when the method execution finished, it corresponds to the stack frame is flushed. We can say that when method execution started, stack memory is allocated to that one, a particular section is allocated to that one, and once the method got end, at the same time the memory got flushed and it got deleted. Now let me talk about the key features of these stack memory. If we are talking about the key features, for the stack memory. Okay, so the first thing which we already told is that it grows and shrinks as the new methods are called. If we are calling any method, suppose we have created one method, and whenever we call any method, then the stack memory is allocated to that one. So it grows at that time. It grows, and when it shrinks when the method execution ends. It grows and shrinks as new methods are called and returned. Okay, when we are calling any method and when the method is returned at the end, then on the basis of this one, stack memory grows and shrinks. Second thing is that variables inside the stack exist only as long as that method which is being created is running. Suppose you have created any method and there are variables inside that particular method. There are multiple variables inside that method. For example, I will show you. Suppose you have created one method like this, public void m1. This is the method, and inside this method you have created a variable like this. Okay, this is the variable you have created inside this method. This is the variable. So whenever you will call this method, suppose you are calling this method inside the main method. Okay, suppose this is the main method, public static void main, string argument array. So this is the main method, and suppose if you called this method, if you are calling this m1 method inside the main method, okay, you are calling this m1 method, you will need the reference to the object. You need to create the object of the class, then you can call this m1 method using that reference. But I am directly saying that you are calling this method. You can mark it as static in order to call directly inside the main method. Okay, so when you are calling, when the execution of this method starts, when you call that method and your cursor will go here at this position, then the stack memory will be allocated to this method. And when stack memory is allocated, then these variables are also created, and the stack memory is allocated to these variables when the method execution is started. And when method comes to the end point, which is the last line of this method, and when the method execution ends, it will back return to this step. At that time, what will happen? The memory which is allocated to these variables which are inside this stack memory, this got flushed, and even the memory allocation which is allocated to this method, this particular method is also got flushed. Okay, so we can say that variables inside the stack, exists only as long as method that is created is being executed or is running. Method that creates them is running. Okay, so the method which created these variables, the variable which is inside the stack memory, until that method is in running state, that particular variable will have the existence inside the stack memory, that will occupy the space. As soon as that method stops running and the execution got completed, that stack memory got flushed. No longer it will occupy this memory, it got flushed. Okay, so the third point, automatic allocation and deallocation happens here. Okay, when the method execution is started, stack memory will be allocated directly, and when the method execution ends, it will automatically deallocated. So this is another key feature for this one. We can say that automatic allocation, automatically allocated, okay, allocated and deallocated. Stack memory is, okay, this way. Stack memory is automatically allocated and deallocated when the method starts and when the method finishes. When the method finishes execution. Okay, when the execution starts, the memory will be allocated directly, and when the method execution finishes, that memory will automatically got deallocated. Okay, and there is one more point. All the memory allocations which we are doing, whether it's a stack memory or it is a heap memory, all these have a limited space inside our system. It's not like that it will get created and keep on increasing. There is a limited space for that one. If that memory space got full, okay, if stack memory is full, then what will happen? Java will throw an error. Okay, Java throws one error, and what is that error? It will throw a stack overflow error. As this is the stack memory, then Java will throw one java.lang stack overflow error. Okay, stack overflow error. This mainly happens whenever we are calling multiple methods inside any method. If we are calling or we are using it something like that, looping, whenever there is looping happens, that we are calling method inside the method, method inside the method, then what will happen, that stack memory will keep on increasing and we are allocating some multiple things inside that one, but none of the method is getting completed. Until any method got complete, it will not deallocate that particular memory. So if we are calling method inside the method, method inside the method, then in that case, maybe there is a possibility that stack memory got full in that case. And in that case, what will happen? Java will throw you an error of stack overflow. This error will be thrown in that case. Okay, now another key point is that basically stack memory access is faster than the heap memory. If we compare the access of this one, then access to the stack memory is faster in compared to heap. Access to stack memory is fast when we compare with heap memory. Okay, and stack memory is thread safe. If there are multiple threads running at same time, we will discuss about threads later on. We can take one example. Suppose that if we are executing Chrome in multiple windows at the same time, 5 to 6 Chromes are being executed at the same time, and the same code is being executed in all the Chromes. So what we can say, there are multiple threads getting executed at the same time. So what will happen? This memory is thread safe. The data will not mix up in all the threads. One thread which is being executed, the data corresponding to that one will be limited to only that particular thread. It will not mess up with the other threads which are being executed at the same time. So we can say that stack memory is thread safe. Okay, as each thread operates in its own stack. What is that one? Whenever we execute any method or execute any code, I already said that stack memory is being allocated to that one. So what happens in the stack memory? Suppose this is the stack memory container and we executed any one method. So this is the part which is being allocated to that one, and that part of code will be stored in that stack. And if we are executing another stack, then there will be another part of code. There is one more section which is being created to another execution of the code. So all these two stacks are different. These are running at different positions and all are allocated differently. Okay, so there will be no mix up in these. One thread which is being executed is inside this stack memory T1, another thread which is being executed in T2. So there will be no mess up in all these. So that's why we can say that stack memory is thread safe, as each thread operates in its own stack. Okay, so these are the key features of the stack memory. Now if we move forward and if we talk about heap memory. So what we can say here is that heap space is used for dynamic memory allocation of Java and JRE classes at runtime. Whenever we execute any code or at the runtime, if there are any things happening, then that thing is being stored inside the heap memory. Okay, what are those things which are stored in the heap memory? New objects whichever we are creating. New objects are always stored or created inside the heap memory, inside the heap space or is heap memory. Okay, so new objects are stored inside the heap memory always, and the references to these objects, if suppose we are creating any heap memory or we are creating any object, suppose the class name is A, then we are creating aref is equals to new A, something like this. This is the object of the class. So this whole object, whole copy of the class, all the variables and methods of the class will be stored inside this object. Okay, so this is the object which is stored in the heap memory. All this will go and sit inside the heap memory. But the reference whichever we are giving to this one, what is the reference name? This one, this ref, that will go and sit inside the stack memory. References of the objects are stored inside the stack memory. Always remember this point. Stack memory will store the reference of the object, and whole object, the new object whichever we are creating, will store inside the heap memory. Okay, so the new object are always created inside the heap memory, and the references to these objects are stored inside the stack memory. Okay, so these objects can be accessed anywhere inside any class or any variable, whichever we are any method or any class. It doesn't matter that whenever we are creating the object of any class, then that will be accessible only inside that class. We can access the object anywhere inside any class. So we can say that objects have global access. We can say this point, that objects have global access. Okay, we can access them anywhere inside the application. Okay, now if we talk about key features. Then what are the key features for heap memory? The first point is that if the stack memory got full, then Java will throw this java.lang.stack overflow error whenever the heap memory got full. If heap memory is full, then what will happen? Java throws java.lang out of memory. This time it will not throw the stack overflow, it will throw out of memory error. Okay, this time Java will throw out of memory error. So you can uniquely identify it is this error is being thrown due to which reason. If it is displaying stack overflow, then you can say that stack memory got full, and if it is throwing out of memory error, then in that case you can say that heap memory got full. Okay, and the second point is that access to the stack memory is faster, but if we talk about heap memory, access to this memory is slower. Access to this memory is comparatively slower. Slower than stack memory. Okay, this is slower than stack memory. And what another point is that stack memory's allocation and deallocation happens by itself automatically, but in case of heap memory, allocation and deallocation is not happening by itself. We can say that memory allocation and deallocation, memory is not or isn't automatically deallocating. Allocation will happen, but it will not deallocate automatically. Okay, allocation will happen, but if you say that if the execution got completed, then it will free up that space which was being occupied, then that thing is not going to happen automatically. So what we need in that case, in case of heap memory, garbage collector is used to free up the unused space of the heap memory. So garbage collector has the responsibility to check the heap memory space, and if the things which are not being in the used, then it will remove those things from the heap memory. Okay, so we can say that for this point it needs garbage collector to free up unused space or unused objects. Okay, and another point is that stack memory is thread safe, which we earlier talked, but heap memory is not thread safe. Heap memory is not thread safe. Okay, and it need to be guarded. We need to make our code in such a way that it will not mixed along with the another threads which are being running at that time. So for that thing, what we can do, we will do the proper syncing. There is one point inside the Java, that is synchronization. Then we will follow the synchronization in that case. Okay, that we will discuss later on in our classes. So we can say that it needs to be guarded. Guarded by properly synchronizing. Okay, synchronizing the code. So these are the basic key features of the heap memory. Okay, so now let me take some code for an example of that one. Suppose we are creating any class. Okay, let's take an example of a class. Suppose there is a class student. Okay, inside this class student there are multiple variables. Okay, there is one int roll number, okay. Another one is a string student name, okay, and there is one constructor inside this one. We are creating one public constructor for this class, and inside this constructor we will pass two parameters. Whenever anyone will call this constructor of this class, he need to pass two parameters. And what are those two parameters? Those two parameters will be the roll number and the name. So he need to pass those at the runtime. Roll number and name. Okay, so what we will do inside this, suppose if we are creating this roll number, then we will allocate the value of this R number to roll number of our class. And second thing is S name. What we will allocate to this one? We will allocate the value of this name to this particular variable. Okay, this is our class. Okay, let me create one sample code for this one. Okay, okay, let me give the name to this class as memory. Okay, we are creating one class. Okay, so in our example what we have given the name to this class? Student. So we will give this class the name student class. Inside this student class we will create two different variables. One will be the roll number and another will be the student name, and we will create one constructor as well. What will be that constructor which we have created? There is one variable as a roll number and another variable is the student name. So these variables are declared at the class level, and in our previous classes we have already discussed about different variables. So what are these variables? These variables are declared inside the class and outside any method. So these variables are instance variables. Okay, now we will create one constructor of this class and we are passing two variables from here. Now what we will do, we will allocate the memory, or we will use this value, this R roll number we will allocate to roll number. R number is the value which will be given at the runtime when anyone will create the object of this class. Whenever anyone will create the object of this class, the constructor will be called, and inside this constructor what we are doing, we are passing two parameters, one integer parameter and another one is the string. So what we will do, the integer value we will allocate to our roll number, and the string value whichever being passed at the runtime, we will allocate that value to the student name. Okay, this is the first class. Now we will create one more class for this one. Let me create another class. Another class is student test. Suppose I am giving the name to this class as a student test. Okay, now inside this student test, what we will do? Now I am creating one method. Suppose I am creating one method, private static, or we can call it as a public as well. It doesn't matter what we are giving at this time. Suppose if I am giving as a public static. Now what we will give the return type of this method. The return type of this method, what we will give? We will give the class object of this class. The previous class which we have created, we will give the return type of that particular method, this method. Inside another class, there are two classes. First class is the student class, this one, and another one class is the student test. So inside the student test class, what we are doing, we are creating one method which has the return type as the object of student class. If we are returning the object of the student class from any method, then we have to pass student here, and we can give any name, test student. Okay, now we are doing this like this. And now what we will do, suppose we are passing two integers, one ID and one name. Okay, now it is displaying error as of now. Why it is displaying error? As the return type of this method is the object of student class, so we are expecting the object in the return. So we will need to provide one statement as return, and what we have to return from this, we need to return the object of student class. So in order to return the object, we will use new student, and if we create the object of student class, then what we have to do, we need to pass two parameters, as the constructor of the student class is asking for two parameters as the input. One is the roll number and another one is the name. So we need to pass two integer values inside this one. Okay, and what can be those values? If you can check this method test string, so inside this test string we are taking two values as the input parameter, ID and name. What we can do, we can allocate these values here. Okay, now you can see the error got removed. What we did here is that we created one method which has the return type as the object of the student class, and in this method we are returning the new object of student class. And from whenever we are creating the object of student class, we need to pass two different parameters. And what are those two different parameters? One need to be the integer value, another one need to be a string value. So these two values we are passing from the method here, method definition, from here we are passing. Okay, now what we need to do, we need to call this method, test student method. And how to call this one? We will create one main method inside this class, public static void main string array args. As we are creating this method as a static, then we need not to create the object of this class. We can directly call this method, but as of now we need to provide two values to this method as well. One need to be the ID and another need to be the name. Suppose we are creating one ID here as well. ID, let it be 420, and the name could be Siddharth. Okay. Now we have created two parameters here. Okay. Now what we have to do is that, suppose now we are calling the students class. In order to call or in order to create the object of a student class, we need to declare this variable student, and then we need to pass one reference name for this one, stu stud. Okay, suppose we are giving this one, so this is the declaration. We are declaring that stud variable will refer to the object of this student class. As of now we are not allocating the memory to this one. As of now we didn't allocate the memory to this one. What we just said, stud reference variable will refer to the object of student class. Okay, so now you can check that stud is the reference variable. So where this reference variable will store, reference of these objects are stored inside the stack memory. So the reference variable will get stored in the stack memory, but the object which we were going to create, whenever we create the object of this class, as of now object is not created. When we create the object, then object will go and sit inside the heap memory. Okay, so this stud, and suppose we need to create the object. Now what we will do, we will create the object. And how can we create the object? We can call this method TestStudent. TestStudent method is doing what it is doing. It is creating or returning one new object of the student class, and this stud reference variable is referring to the student class object. So we can allocate this method directly instead of following new student and after that passing this name. We, instead of writing this, we can directly call this TestStudent method here. Okay, inside this method we are expecting two parameters, one integer and one name. Here are these integers, one is the id and second one is the name. We can directly pass this. Now the object got created here, then it will go and sit inside the heap memory now. Okay, now let us analyze this code. What we have written here is that when we enter the main method, okay, when we enter this main method, a space in the stack memory is created to store the primitives and references to this method. Okay, whenever we enter in the main method, there will be a space being allocated in the stack memory. Okay, what it will do, it will store the primitive values and the references. All the references will go and sit inside the stack memory, and the primitive values, these are the primitives will go and sit inside the stack memory. Okay, then what we can say, the value which is being allocated to id, that will go and store in the stack memory directly. Another thing is the reference variable which we are giving to this stud. This stud reference variable of this type student will go and store in the stack memory. This will also go and sit inside the stack memory. This is also getting stored in the stack, and this stud is also going to store in the stack. Okay, this will also go and sit inside the stack. Now whenever we are calling this parameterized constructors, inside this we are directly calling this parameterized constructor. You can see this inside this method we are calling this parameterized constructor. Okay, whenever we are calling this parameterized constructor, this will allocate another memory on the stack at the top of that one. Okay, this object reference will be calling an object in the stack memory. And what is here, we are calling one id and one name inside this one. So this id and name will go and sit inside the stack memory. The reference variables will be stored inside the stack memory for this one. Okay, but the actual string value that is coming from the string pool, that will go and sit inside the heap memory. Okay, and whole object which is being created, this one which is being created by the return type of this method, this will go and sit inside the heap memory. So mainly we can say that all the objects which are being created are stored in the heap memory, and the references and the primitive values which are being created, these will go and sit inside the stack memory. Okay, so if we talk roughly about this one, then we will go here and suppose like this. Okay, here we have a class. What is the name of that class? Student. And we are calling one constructor for this one. One is the int value and another one is the string value. Another one, we have one method as well. What is that method which is returning the object of the class? TestStudent method. It has one integer and one string. One more method is there, that is the main method, which is taking a string array as the input. Okay, now if we talk about the different variables which are being created. Okay, there are different variables inside this student. This is, what is this one? This is the object, and what it is calling, this student is calling, suppose if we are talking about this, this one, then it is calling one integer, that is integer value, and what is the value of that one? The value of that one is 420. We are passing this ID as 420 here. Okay, so the value of that ID will be 420. Another thing is that inside this constructor, what we are doing, there is one string reference. What is that one? A string reference inside the constructor is the name. This is the name. And one more thing is the person reference, student reference. It will refer to that particular object of this student class. So all these values and all these things, and inside this test method, test student method, we are doing the same thing. If you go and check this test student method, we are passing integer ID, string name, and it is also returning the student class object. Okay, so in the same way we are calling same things inside this method. Okay, so string reference, what is the reference of that string? Name. What is the integer value? We are passing inside test student method ID, that is 420, and the object name is student. So all these things, and inside if we go and talk about the main method as well, what is inside the main method? ID, name, and we are calling this test student method, which is indirectly referring to the student. So all these things are happening inside all these three methods. So if we talk about integer value ID, then that will go and sit inside the stack. You can directly say this thing. All these methods whichever we are calling, student object is calling one integer and a string, test student method is calling one integer and a string. Main method is also calling few things. So what is that one? Integer, whichever these are calling. What is that integer value? id is equals to 420. String reference, we are talking about reference only. String reference is that, what is the reference? Name is the reference. And whenever we are calling the student reference, then this. So all these things will go and sit inside the stack memory. If we are talking about the reference of the student, then that is stud as well. Inside this main method, and one more method is there. If we are talking about this one, main method we are calling stud. So in here, student reference for this main method will get changed. Student reference will be stud in this case. Okay, in the case of main method. And inside main method as well, we are calling this test student method. So test student method is also referring to stud here. So indirectly test student method will also refer to this stud. So only this student has a reference of this one, and these two methods are having the reference name of that student as the stud. So these reference name, stud reference name, will also go and sit inside the stack memory. All these things will go and sit inside stack memory. These are the things which are going to be stored in the stack. What is that one? First is the integer, that is id is equal to 420, that will go and sit inside the stack. The second thing is the string reference. We are just talking about the reference, not the value of that one. The reference will go and sit inside the stack memory. The third thing is student's object, which we are creating. The reference of that object will also go and sit inside the stack. So these are the things which are going to sit inside the stack. Now if we talk about the heap memory, then what will be inside the heap memory? Inside the stack we are storing the string reference. We are just storing the reference. So what will be the value of this name will go and sit inside this heap memory. What is the value of that one? Siddhant. And this value is being stored where? This value is being stored inside the string pool. From the string pool we are calling this value, so this value will be present inside the heap memory. Okay, and whenever we are calling the values inside these objects, stud and all those, this stud, whenever we are calling these methods inside this here, this stud, so values are being allocated to this thing as well. 23 and name, these will also get stored inside the person's object. We are storing all the values, or we are creating the object here. Student stud, and at this step we are creating the object for this stud. So what will happen? The stud object, the object whichever we are creating, that will also go and sit inside this heap memory. This one, student stud object, will also go and sit inside the heap memory as well. Okay, so we can directly say that values, integer values, primitive values will go and sit inside the stack memory. String references will go and sit inside the stack memory as well. Objects references will also be stored inside the stack memory. And whenever we are talking about the values of the string, that will being called by the string pool, so these are being stored inside the heap memory. And the objects whichever we are creating, all the objects will go and sit inside the heap memory. Okay, but as of now this is all about the memory allocation in Java. Thank you everyone for this one, and please do watch and subscribe our channel. Please share and subscribe if you like the videos inside that one, and thank you everyone.